Okay, today we'll start another types of differential equation, exact differential equations of first order. Actually, in previous we have studied about the first ordinary differential equations of first order in a variable separable method, a linear differential equations method, and now we will study about exact differential equations of first order actually. So today we will start with exact differential equation. Actually, this is the differential equations and types of these types of differential equation can be written as m dx plus n dy equals to 0. Actually, m and n are the function of x and y. So function of x and y, m and n. So if we can write the differential equations, given differential equations in this way, then the differential equation will be exact. There is a condition for this and theorem for this to exact differential equations. Now a differential equation m and n is said to be exact differential equation in region R in the xy plane, because there are two variables. One is a dependent variables y and another is independent variable x. So this is the in this plane will give a differential solution in xy plane, and if it corresponds to the differential equation of some function f of xy in defined in R, a first order differential equation can be written like this in previous, look like previous slide. M dx plus n dy is said to be exact if the expression on the left hand side is an exact differential equation. So the main theorem or main criteria for this, we have to use a condition for this. Actually, del m del y equals to del n del x. That means m, a partial differentiation of m with respect to y and partial differentiation of n with respect to x will be equal. Then we can say that the differential equation is exact. Which one? These types of differential equation, m dx plus n dy. Now we'll study an example for this related with this. Okay, we have already known that exact differential. What is actually exact differential equation? An exact differential equation is found by the directly differentiating its primitive without any the other process. That means m dx plus n dy equals to 0. This is a differential equation where m and n are the function of x, y only. Remember it. And this differential equation will be said to be exact differential equation if it satisfies this condition. This condition what actually? Partial differentiation of m with respect to y equals to partial differentiation of x with respect to x. If this is equal, then you can say that this is exact differential equation. Okay, this is the main condition for this. There is a procedure for this. So for the solving of exact differential equation, actually, step one, first of all, we have to integrate m with respect to x, keeping y as constant. We have to remember this process. And and in step two, integrate with respect to y only those term of n which do not contain x. Then result of the solution will be first step plus second step equals to constant. Now let us consider a example for this. Solve this differential equation equals to 0. That this is look like this: m dx plus n dy equals to 0. Okay, where m equals to what? 5x4 plus 3x square y square minus 2x y cube, and n what will be 2x cube y minus 3x square y square minus 5 y to the power 4. This is the m and this is the n. So this is look like what? M dx plus n dy equals to 0. Now taking partial differentiation for this, taking partial differentiation with respect to y, that means x will be constant. You must know about partial differentiation. So taking partial differentiation of m with respect to y, that means this will be constant 0. So y square differentiation what? Twice y only. That means 6y square y, and this will give what? 3 to 6 xy square. Just taking partial differentiation with respect to y, x will be constant for that. Now taking partial differentiation of n with respect to x, what will be? Just taking in differentiation with respect to x, 6x square y, and this will be 6xy square, and this will be the constant term, because in partial differentiation with respect to x, y treated as constant. Remember it. So we got actually del m del y equals to del n del x. This is equal, right? So we can say that the given equation is exact. Otherwise not exact. If this is not equal, then it will be not exact. So the required solution what will be? We have to integrate m with respect to x. integrate m with respect to x. Okay, m what is this? This is the first part, coefficient of dx. So and integrate n not containing x, not containing x, which one? That means minus 5y4. There is no x actually. So we can the term we can take the term not containing x, what will be? Minus 5y to the power 4. And m is what? This. Now taking integration with respect to x, m, and taking integration with respect to y for this term, we get this equals to c. This is the required solution, and this is the general solution for the differential equation, not particular. If we assigned any value, initial values for x, for any initially for any independent values, we get, if we use any dependent variables value, then we can find out the value of c. For a different finds different values of c, we can draw this curve. Actually, this is the solution curve of this differential equation. Exact equation, that means exact differential equation of ordinary differential equation and integrating factors. Actually we have to we need to solve exact differential equation with integrating factors sometimes. Consider any differential equation, ordinary differential m dx plus n dy. That means y dash means what? Dy by dx. Okay, y dash means what? First differentiation with of y with respect to x. That means dy dx. That means what? M dx plus n dy equal to 0. Suppose this, there is a function, another function, psi of x. That means equals to mxy, and this psi of y equals to nxy. That means m is the function of xy, and n is the also function of xy. So if we can take this, if you can form this whole left hand side, this is the whole left hand side, ddx of UV process, ddx of UV process, function of UV process. That means if we can represent this left hand side in this way, then we can write the solution of this differential equation, psi of xy equals to c, and this will be the exact differential equation. This is another process. Just we need to understand only one process. Now for the, there is a theorem for this. We know del m del y equals to del n del x will be equal for this in the xy plane. Then the given differential equation will be exact. That means partial differentiation of y and of m with respect to y, and partial differentiation of n with respect to x will be equal in the xy plane. Okay, in the xy plane what? This is the function of two variables, one is dependent variable and other is independent variable x. So this is the we have to, if we plot the graph of solution of differential equation in xy plane, then we get the result in xy plane. So if we try to solve this differential equation, suppose dy dx equals to this, and you can write in a standard form m plus n dy dx. That means m dx plus n dy. Okay, taking partial differentiation with respect to x, here m equals to x plus 4y and n equals to what? 4x minus y. So partial differentiation of x with respect to y, what will be? Only 4, x will be 0. And here partial differentiation of n with respect to x, what will be? 4. That means both partial differentiation are equal. So this is the exact differential equation. Now using the method integrating m with respect to x plus the term containing in n not containing in x, that means only y, adding this equals to c will be the, will give the result by using the theorem del m del y equals to del n del x. Okay, so we get the actually solution of the differential equation, what? This half x square plus 4xy plus half y square equal to, okay, understand? This is the solution of the, just integrating m with respect to x, what will be? X square by 2, and integration m with respect to x, what will be? 4xy. Now in n without without term x, what? Minus y. So minus y integrating with respect to y, what will be? Y square by 2. Just adding this equals to constant. Actually this is the result. Okay, this is the result. X square plus 8xy minus y square equal to c is the equation of this, of the differential equation of this. Understand? Now directional field and solution, what will be the actually this term? Directional field and solution. Actually, this is the exact differential equation, and we have solved it, and we got the solution x square plus 8xy minus y square equal to c. Actually, for different values of x and y, and this is the constant term c, and for different values of c, we can plot this by using programming method. Different kinds of software, you can use MATLAB or any other software, or Python also, or C++ or C you can use. X square plus 8xy minus y square equal to c. This solution of this differential equation will give the graph this. Okay, for different values of c we get different kinds of. Actually, in every point there is a directional field. That means dy dx, rate of change of y with respect to x in every point. This way there are many arrows. Actually, this is the direction of the curve. Actually, the curve of the direction field, direction field for this differential equation along with several solution curves is given by value. That means for several values of c we get this 1 2 3 4 5, right? This curve you can plot if you know the solve the with the MATLAB. Okay, now explicit solution of this given. Actually, we got the solution of this differential equation of our given differential equation. We can solve this by in quadratic case. Okay, quadratic of y square equals to, we can write this differential equation like this: y square minus 8xy minus x square minus c equals to 0. That means y equals to what will be? This is the quadratic x square plus bx plus c types equation. Quadratic equation, do you know? Quadratic equation x square plus bx plus c equal to 0, where y is the variable and x all are constant. That means x square plus bx plus c equals to 0 will give x equals to minus b plus minus square root b square minus 4ac divided by twice a. Using this relation we get y equals to 4x plus minus 17x square plus c. For different values of c we get the real value of y, and using values of x, different kinds of graph we got. Solution curves for several values of c will give this. This is the actually hyperbola. This is the equation of hyperbola actually. So by plotting we get this solution. Okay, now another example. Consider the differential equation y cos x plus twice x e to the power y equals to plus sin x plus x square e to the power y minus 1 and y dash. That means dy dx equals to 0. This is the actually standard form of exact differential equation, m plus and dy dx equals to 0, where m equals to this and n equals to this. Taking partial differentiation of m with respect to y, this, and partial differentiation of n with respect to x will be this. Taking partial differentiation. So these both are same. So we can say that the given ordinary differential equation is exact. Now just using theorem, integrating m with respect to x, and in n the term containing without x. The term containing without x, which one? Just one. Okay. Now integrating this with respect to y, we get the our original solution of the given differential equation like this: y sin x plus x square e to the power x minus y equals to c. Just by using theorem, they have used another theorem, but we are using our first examples theorem, right? Just y sin x, just integrating m with respect to x, we get this part. And in n without x containing, without containing x is this only one. Okay, minus 1. So integrating this we get this, and this will be equal to c. This is actually our required solution of the given differential equation. Now direction, we can plot different directional field and solution curve for this differential equation. Actually, this given differential equation give the solution of this. A graph of the directional field for this differential equation along the several curves is given value. Actually, for several values of c we get these types of curve, because there is a sin x and transcendental equation is this. For different values of c we get this. Okay, this is the actually explanation of exact differential equation and how to solve by using different kinds of software, such as MATLAB or Python or C++, etc. Okay, now we will try to solve the exact differential equations by using initial value problem. Okay, suppose there is a problem, solve the following initial value problem. This is the actual initial value problem. This is the differential equation, and y0 equals to 1. That means there is an independent variable, what? T. Without x, we are using t variable, right? So dependent variable, what? Same, y. So for t equals to 0, y equals to what? 1. This condition is called initial condition, okay, for this problem. So this is the initial value problem. Now we know the given equation can be written as like this: m dx plus n dy types equals to 0. Okay, here dx means what? Dt. We are using t in replace of x. That means m dx plus n dy equals to 0. Then which has the form m ty. That means xy means what? Ty variable. T is using with in replace of x. So m ty dt plus n ty dy equals to 0. That means exact form. Where m equals to this and n equals to what? This. Now taking partial differentiation of m with respect to y. Okay, taking t as constant, remember it, t will be term as constant. So partial differentiation of m with respect to y will be differentiation what? 1. So only this. Now cos y differentiation what? Minus sin y. Okay, 2t is the constant. Now taking differentiation of n with respect to t, e to the power twice t, formula what? E to the power twice t, but multiplying with the coefficient of t coefficient of t what? 2, just multiplying with by 2, minus t square differentiation what? Twice t, and sin y is the constant. So these two are same. So we can say that this is the actually del m del y equals to del n del t. So the given differential equation is exact. Now integrating m with respect to t, keeping y as constant. Look like our first example of this lecture. Integrating m with respect to t, we get this. Now in n free from t, which was in n free from t, no term actually. So this will be 0. So the required solution will be m dt plus integration of n without containing t dy equals to c. So this is the actually required solution. Just integrating this we get. Now imposing our initial conditions, y0 equals to 1. That is what? When t equals to 0, y equals to 1. Do you know? 0 means what? T. This is the function of yt. This is y. So if t equals to 0, then y equals to 1. Now putting t equals to 0, y equals to 1 in equation 2 will give 1 into e to the power 2 into 0 and 0. That means c equals to what? 1. So this is the actually required particular solution. You must know about solutions of differential equation. There are three types of solutions of differential equation. One is singular solution, other is particular solution, and other is general solution. From our first lecture, we must know about the solution of differential equation. Actually, this is the particular solution because we have assigned the value of constant c. Okay, c equals to what? 1. Just putting the values of c, we got this solution. This is why it is called particular solution. And this is the general solution. Remember it. Containing constant will be containing constant. This will be what? General solution. Actually, first order why? First derivatives containing in this differential equation, only first derivatives dy dt. This is why only single constant. If there are second order differential equation, constant what will be? 2, and third order constant will be 3, and in fourth order constant how many? 4 constant. So we get the value of 4 constant. This is the actually required solution of the initial value problem. Now we can solve another differential equation like this: y by t plus cos t dt with respect to t. Okay, e to the power y ln t dy equals to 0. Where the initial value given for t equals to pi, y equals to what? 0. The given equation can be written as the like this form: m dt plus n dy equals to 0, which has the form this. Okay, now taking partial differentiation of m with respect to y, we get only what? Y will be 1. This is y 1 by t, and this will be 0 because in partial differentiation t will be 0. Now taking partial differentiation of n with respect to t, what will be? E to the power y will be 0, and ln t, what formula? Ln x formula what? 1 by x. This is why ln t will be 1 by t. Now we got del m del y equals to del n del t. So the given differential equation is exact according to our desired theorem of first problem. So now integrating m with respect to t, keeping y as constant, we get this. Now in n without containing t, which one? Just e to the power y. Okay, e to the power y. So our required solution is this. Just using first example of this lecture. Remember it. Now imposing our initial conditions, y pi equals to 0. If t equals to pi, then y equals to what? 0. This means what? If t equals to pi, then y equals to 0. Now using this condition in equation 2, this is the solution of our exact differential equation. Just putting y equals to 0 and t equals to pi, we get c equals to 1. Sin pi equals to what? 0. And this is also 0. E to the power 0 equals to what? 1. This is why c equals to 1. Hence the required particular solution will be just putting c equals to 1 in equation 2. We get this particular solution. And now using this method, you can solve many problem of initial value problem. Okay, this is the exact differential equations of solving initial value problem. Mm. Now we will discuss a engineering application of this differential equation, of first order differential equation. Suppose there is a RL circuit with a step input. Write down the differential equation governing the current I flows in the RL circuit shown in figure 19.2 when a step voltage of magnitudes, this is the voltage E, is applied to the circuit at time t equals to 0. So the differential equation to obtain IT. Okay, it is the function here. Independent variable is t, time, and I is the what? Dependent variable, look like y. So when there is a given condition, when I equals to 0, t equals to 0. Actually this is the circuit. Okay, this is the given circuit, and this is the resistance. L is what actually, you know? Can you say L is what? Electric conductance, right? Or resistance, which one? L at time t equals to 0, closed. That means this is the battery positive part and negative part, and is the electric voltage. So we will try to applying a Kirchhoff's law of voltage law and Ohm's law to circuit. Uh, Applying in this circuit, we find the differential equation. This is the IR. Actually I and R, this is the total electricity. Total B equals to IR. Remember, you must know about this formula, B equals to IR. So this is the IR plus L, the rate of change of electricity with respect to time, L di dt, equal to what will be total voltage, where time t must be greater than equal to 0. That means t can never be negative, time can never be negative. Now applying Kirchhoff's law, we got the voltage law and Ohm's law of the circuit. We find this. This is the actually differential equation. Remember it, because first differential coefficient is containing in this equation. So this is the differential equation of what? The given circuit. That is L di dt equals to what? E minus dir. So that here we can solve actually by variable separable method, right? Variable separable method using L divided by E minus IR di equals to integration of only dt. Just variable separating. This is the differentiation with respect to I, and this is the differentiation with respect to t. So we get this integration, what will be? Minus L by R, and this is the integration of minus taking R on both sides. Okay, this R and this R will be cancelled, but we have taken this. If we take differentiate of the denominator, we get numerator, right? So this is the formula of 1 by x. That means ln x formula. 1 by x formula integration what? Ln x. If we take E minus IR differentiation, we get minus R only. E will be constant 0 and I will be only 1. This is why minus R. And this is this circuit formula by using variable separable method, we get this minus L by R. This equals to t plus c. One integration what will be? Only t plus c. This is the constant. To find the constant of integration c, we have to apply the given initial value condition, the physical condition when I equals to 0 and t equals to 0 provide this. Applying I equals to 0 and t equals to 0 in this solution of this differential equation, c equals to what will be 1 by L by R ln E. Okay, I equals to 0. I equals to 0 only ln E. Okay. Now substituting this value c, we get, putting this value c here, we get this. Thus, taking L by R common from these two, we get this equation. Okay. Now L by R ln log m minus log n formula. Log m by n. For minus, we have to use division. This equals to, so ln equals to, this equals to the L by R, take multiplying both sides R by L on both sides. Okay, we get this. Hence, now removing ln, we have to take exponential form, e to the power this, e to the power this, RT by L. Okay. Now rearranging to obtain E gives equals to what will be, just arranging this equation, we get this. Hence, total EMF, total EMF, electromotive force, E equals to this. So we can write E equals to what actually? So this equals to, substituting, taking E common from this, we get this, and IR equals to this. Dividing by what? E to the power RT by L. Dividing on both sides, we get IR. Where I equals to, this is the actually result. This is the solution of this given circuit problem. Okay, given circuit problem, what? For this circuit, we have made a differential equation and we solved it for I using the initial condition t equals to 0 and I equals to 0. Okay, so this is the actually required solution using different times of different t values of t. We have used another components here, tau equals to R by L. Okay, tau, a time constant. It is a time common time. It is common to define a time constant tau for the circuit. Tau equals to what? L by R. Okay, the equation of the current can be written as this. The smaller value of tau, the more rapidly current reaches its final value. For a smaller value of tau, we get more value of I. Okay, so in laboratory test, by noting that after one time constant, that is, if t equals to tau, I has reached e to the power minus 1, that means 0.63 constant of its final value. This is the actually final value and highest value of I. Okay, using what? T equals to tau. This is the actually an application of differential equation of first order in engineering, actually especially in electric engineering. Okay, now another engineering application for RL circuit. Recall that the standard ramp function for the value less than t, 0 t less than 0, and a value ct t greater equal to 0, showing the this figure actually. A voltage ramp signal with a value c equals to 1 is applied to RL circuit. This is the actually RL circuit. The arrangement is shown in figure. The differential equation is this for time t equals t is non-negative, and initial value I0 equals to 0. That means for t equals to 0, I equals to what? 0. This means what? You know, for t equals to 0, I equals to 0. So that the equation can be written in the form equation this. Hence, use the integrating factor method to find out this. This is actually, this is the application of linear differential equation of first order. Our previous lecture. The equation can be written as this: di dt. This is the differential equation. Di by dt and plus R by L I t by L. Okay. Dividing R, dividing by L on both sides. Okay, we get this, which is the first order linear differential equation. This look like dy dx p py plus py equal to q, right? This is the linear differential equation of the standard form, where p equals to R by L and q equals to what? T by L. The integration factor what will be? E to the power p dt. Actually, independent variable is t here. This is why p what? Actually, P is the coefficient of dependent variable, right? P is the coefficient of dependent variable. Follow the previous lecture, okay? Linear differential equation chapter. E to the power r by L. So with respect to time t, integration what will be? T only. E to the power r t by L. Now multiplying this integrating factor on both sides, what will be the solution of this linear differential equation? What will be? Just dependent variable into integrating factor equal to integration of right hand side into integrating factor. Okay, follow the previous lecture of linear differential equation. So 1 by L integration, just multiplying. What will be the integration of this? Actually there are multiplication of two function of t. Okay, multiplication of, that means UB process, u into integration of b minus differentiation of u integration of b, again integration. Okay, now here taking t is the u and e to the power rt by L will be b, t u into integration of b, that means e to the power rt by L, e to the power x formula, e to the power x, dividing with the coefficient of what? Variable x, variable t, sorry, here t is the coefficient of t, what? R by L, dividing with the coefficient of r by L. Now t differentiation what? 1, again e to the power x formula, e to the power x, dividing with the coefficient of t, R by L, again integration. This integration what will be? E to the power x formula, e to the power x, again dividing by with the coefficient of coefficient of what? T, R by L. So there will be r square by L square in denominator. So 1 L will be cancelled when multiplied by 1 by L, 1 by L. So we get, this is the actually result of the given linear differential equation of the circuit. Now where k is the constant of integration, the general solution will be this, dividing with the e to the power rt by L on both sides. Okay, we get this k into minus, this will be cancelled. Okay, this will be also cancelled, divide on both sides. When t equals to 0, I equals to what? 0. Using here we can find out the value of integration constant. The initial value gives the, to find kilo. Applying a equals to 0, k equals to what will be? This. Just I equals to 0 and t equals to 0 will give k equals to e to the power 0 equals to only 1. This is why k equals to this L by R square. Putting k equals to L by R square in this solution, we get the particular solution of the given differential equation of the circuit. Understand this? Okay, I hope everybody can do this and do practice at home. I hope everybody can do. Okay, we have solved initial value problem, exact differential equation, this 1 and 2 we have solved in this lecture. Now homework for you 3, 4 and 5. You see, actually this is from book Jill and I have solved it. Actually dy dx equals to this, for x equals to 0, y equals to what? 2. This is the actually problem procedure. You can use this method, same process actually, and we got the particular solution of this given differential equation. Now just you have 3, 4 will be your homework. Okay, initial value problem, you have to practice.